Today's lecture will be taking permutation and combination. Permutation simply means arrangement. There are different arrangements we can make out of a given set of things by taking some or all of them at a time. That is what we call permutation. Look at the letters A, B, and C. If I pick one, I pick two, pick three pairs. So when we talk about permutation, what's the formula? It just means n permutation arrow. That you have the number of permutation of n different things taking arrow at a time. Normally, the general principle that guides us is if one operation can be performed in n different ways and they corresponding to any one of such such operation, if the second operation can be performed in a different way, the total number of performing the two operations will be n times n. Now, when we talk about permutations of things all different, if we have I can say this is like finding out the number of different ways in which arrow places can be filled by n things taking one at a time. If one place is filled, then the second place can be filled in n. If one place is filled, that is n ways, the second place can be filled by n minus 1 way. The other third place can be filled by n minus 2 way. The fourth place will be n minus 3 ways. That's what you see. Till you now have n factor. Now, this is just a basic theory you just need to know in permutation, that n permutation n is equals to n minus n. N permutation n is equals to n permutation n minus 1. Now, we need to know about factorial notation because you are going to use it. When you talk about factorial, it's just a multiplication of a first natural numbers. You have n factorial is like n 1 times 2 times 3 dash dash to n minus 1n. Now, if I have 5 factorial, I can say 1 times 2 times 3 times 4 times the last number. What's the last number? 5. I can also reverse it another way to say 5 times 4 times 3 times 2 to the last natural number 1. So you can see it's on textbook. You start from 5, 4, 3, 2 times 1 multiply. But here in the textbook I'm using, we are starting from 1. Don't let that confuse you. You can either start from 1 or you can start from the number. Talk about factorial, it's just a product of a natural number starting from the first one. You can start from 1 or you can start from that particular number. Look at 7 factorial. I can start from 1 times 2 times 3 times 4 times 5 times 6 times 7. I stop at 7. I can as well use it the other way by starting by 7. 7 times 6, I've reduced 7. 7 times 5 times 4 times 3 times 2 times 1. Or I can also say 7 times 6 factorial. Now, what's the formula for n permutation arrow? This is the formula. N factorial over n minus arrow factorial. N factorial over n minus arrow factorial. Now, the permutation of things when they are not all different. To find the number of permutation of n things taken all together, the things are not all different. Supposing you have n things to be represented by n letters, and p of them are said to be a, p are equal to p of them are equal to a and q of them, then p of them also are equal to p, and one arrow of them are equal to c. What is just saying that if, for example, you have the letter, the word purpose, in how many ways can you arrange them together? If you look at the letter purpose, you count the letters, you see there that there are seven. That is 7 factorial. Now you now ask yourself, there are two p's there. There are two p's that repeat itself. So that you have 7 factorial over 2 factorial because you have two p's. It's the same way this is the formula you use. When you have numbers and in those numbers you want to arrange them, like you look at how many of those numbers are like you have equal. Like p, you have 2p. So you now have 7 factorial over 2 factorial. Permutations of things that may be repeated. So you see that n things can be taken, n different things are taking arrow at a time, in which any item can be repeated without restriction. The number of the possible arrangement will be n factorial. Now, permutation in circle or in a ring. When things are arranged in a row, we find two edges in each arrangement, while the other things are arranged in a circle, there is no such edge. When you arrange things in a row, we find two edges in each arrangement, but in a circle, but there's no such edge. That's why when we arrange things in circle, we take the formula is n minus 1 factorial. When we arrange things in a row, we'll say is n minus 1 factorial. Now, but sometimes when we are arranging, like we want to arrange in a ring we can have, that's like a circle. So if I say I want 20 boys can form a ring, that is n minus 1. So if I say 21 boys form a ring, it will be 21 minus 120 factorial. That's the way I can be arranged it. But if I now want to look at distinction between clockwise and anti-clockwise or counterclockwise arrangement is not made. Now look at 10 beads can be placed in an example 60. 10 beads can be 10 different beads can be placed in a necklace. Now I want to consider 10 beads placed in a necklace. If the distinction between clockwise and anti-clockwise arrangement is not made, then I'm going to have 1 over 2 n minus 1 factorial. Now you need to know about restricted permutations. Number of permutation of n different things taking arrow at a time, in which p can never occur. If I have a permutation of n different things taking arrow at a time, in which p particular thing never occurs, that will be n minus p permutation arrow. Now, keeping aside p particular thing, to fill n place, fill the arrow place with the remaining n minus p. That's what it's just telling us. Now let's see example 61. In how many ways of the permutation 8 things taking 3 at a time with 2 particular things never occur. Now you need to have your n is 8, that's the 8 things. Your arrow is 3, that's taking 3. And your p, that's the restriction, p is equal to 2. So in how many ways can it be taken if 2 particular things will never occur? Will be n minus p by permutation. P, that's p arrow. So that's why you have 8 minus 2. That's 6 permutation 3. 6 permutation 3. Now look at another restriction. The number of permutation of n different things taking arrow at a time, in which p particular things are always present. P particular things are always present. This formula you now use. The first one we used was when two things can never occur. You use this one. Now see example 62, explain it. In how many ways, in how many of the permutation 8 things are taken, 3 at a time, with two particular things always occurring. Two particular things always occurring. Now you come here, your N is your 8, your R is 3, and your P is 2. That's the restriction. So you now say N minus P, that's P R minus P times RPT. So when you say N, that's your 8 things, you're taking 2, your 3 minus 2, that's permutation 3 minus 2, times 3 permutation 2. So that's how we got 6 permutation 1 times 3 permutation 2. So you have 18. Now there are further examples you can do there. Having known the formula for permutation, you know that the formula for permutation here this is the formula to get your permutation P, that's N permutation R. So you now want to use it here to get 7 permutation 5. That simply means 7 factorial over 7 minus 5 factorial. That's how you got that. 7 permutation 1, just 7 factorial over 7 minus 1. 7 permutation 0 will be 7 factorial over 7 minus 0 factorial. 7 permutation 7 will be 7 factorial over 7 minus 1 factorial. That's the solution to that. Now look at this. If you want to find n permutation 2 is equal to, if n permutation 2 is equal to 110, then find n. This is just a simple problem. This is this problem. What you just do is expand n permutation 2. You have n factorial over 2 n minus 2 factorial, which is equal to 110. Now, if you go further to expand, I want to expand n in a way that I can eliminate n minus 2, my denominator. So I'll go further from your knowledge of factorial. n minus 1, multiply n minus 2 factorial. You are going to see I will stop at n minus 2 factorial because my denominator is n minus 2 factorial. So I will cancel this. So I'll be left with n into n minus 1 equals to 110. I just do my simple algebra. Here I can look at what will I use to multiply in 2 digits that will follow each other that will give me 110. That is 11 times 10. So I can decide to equate 11 times 10 is equal to n multiply n minus 1. So my n will be equal to 11. Now the same way you solve this, you have n permutation 4 equals to 30 multiply n permutation 2. What you do, first of all, you expand this n permutation 4, that's n factorial over n minus 4 factorial times 30. N permutation 2 is n minus 2 factorial. When you have done that, you just use your operation and you expand n permutation 4. Now, looking at your denominator is n minus 4. Now, you are going to expand your factorial till you get n minus 4 factorial so that you can eliminate the denominator n minus 4 factorial. The same way you use it, your denominator here is n minus 2 factorial. So you expand n, the numerator n minus 1 times n minus 2 factorial so that you cancel this. Having cancelled this, you'll be left with n into n minus 1, n multiply n minus 2, n minus 3 equals to 30 times n minus 1. You're going to see that this n will eliminate this. So you'll be left with n, you'll be left with, when this eliminates this will eliminate this, you'll be left with n minus 2 multiply n minus 3 equals to 30. So when you do that, you are going to have your simple solution. You can use your multiply this and use this to take this to the other side, and you get your solution. So that's the way you can as well approach that. And you just open this bracket, you have this quadratic equation. This 30 goes here, you have n squared minus 5n minus 24 equal to 0. So your n will be equal to 8 and minus 3. But you know n cannot be minus, it cannot be negative. So your n there is 8. So that you can also look at this other one. It's the same way. Let me look at example 64. In how many ways 6 books out of 10 different books have been arranged in a bookshelf so that 3 particular books are together? Now, 3 particular books are together. In how many ways can 6 books out of 10 different books be arranged? At first, 3 particular books are kept aside. That's 3 factorial. When 3 particular books are kept aside, you are left with 7. So 7 can now be arranged in 7 permutation 3 ways. That's, you are taking 3 out of 7. So now, in between the 3, there are 2 places and at least 2 ends. There are 2 ends. That's 2 places. So now what you are now left with is to say that 3 particular books can be arranged among themselves in this way. So you have 7 permutation 3 times 4 permutation 1 times 3 factorial. The 3 factorial is that when you first you keep 3 particular book aside. Now you now have 3, you are taking 3 out of 7, that you have 7 permutation 3, you are multiplying. Now if you are taking 3 out of 7, you have this. Now in between, you are now left with two places. 2 places, that's 2 places and at 2 ends. So that's how you have 4 places where the book can be placed. 4 places where the book can be placed. Where 3 particular book can be placed, that will be 4 factorial. So if we bring that together, we are going to have 7 permutation 3 multiply 4 permutation 1 times 3 factorial. Let's see this example 68. In how many ways can the letters of the word table be arranged so that the vowels are always 1 together, 2 separate? Now, if you look at the letters table, you have 2 vowel and 3 consonant. Now, if you take, how many ways can they be arranged together? If you take 2 consonant as 1 letter, you'll be left there as with arranging 4 letters because there are 3 consonants. Now, if you take the vowel, 2 vowel as 1, you are going to have 4 letters. So, in how many ways the letter table can be arranged when the vowel sound are together will be 4 factorial times 2 factorial. Now, without restriction, that is to say, the vowel consonant are together or not. So now you have how many letters? There are different letters in this. There are 5 letters in that makes up table. So there are going to be 5 ways. Now, because the vowel sound, when you add the vowel letters rather, altogether is 48. So the way you can arrange the letter table is 5. So if they are the vowel sound are going to be separated, it's going to be 5 factorial minus 48 factorial. This is similar way to when you fist, like example 68. Find the how many ways can the letters of the purpose be rearranged, keeping the positions of the vowel fixed without changing the relative order. 2. Without changing the relative orders to the vowel and the consonant. Now, the first one, if you keep the letters position fixed, now you have the word purpose. You have 4 vowels, you have 3 vowels rather, and 4 consonants. Since the positions of the vowels are fixed, so then you are going to rearrange only 4 consonants. Now, you are going to have, and you know in the letter purpose you have 4 consonants. If you keep the letter of the vowel sound fixed, position fixed, so you now have 4 consonants. Now out of that 4 consonants, you have 2 P's, like you have 2 P's. So you now have 4 factorial over the 2 P's, that's 2 factorial. Now look at the second one. The relative orders of vowel and consonant unaltered means that the vowel will take the place of vowel and consonant will take the place of consonant. Now, 3 vowels can be arranged among themselves, that's 3 ways, and 4 consonants can be arranged with 2 P's. We have done that before, 2 P's. So you are going to have 12, that is this, times 3 factorial. So that's how you have 72. Now, your answer will not be 72 because these ways, the number of ways of rearranging them, given that the arrangement will include it. Now, you now have minus 1 because you were told that the relative order of the vowels and consonants are unaltered. So that's why you have here. I now have 72 minus 1. So my final answer is 71. Yeah, this one is just also similar, but you can read that on your own to avoid repetition. But let me just explain 71 and 72. In how many ways can the letters of the word Sunday be arranged? And how many of them do begin with X? How many of them do not start with S but end with R? Now the letter Sundays, you have the letter 6 that makes us Sunday. In how many ways can they be arranged? That's 6 factorial. That's 720. That's 6 factorial. Now if you place S in the first position fixed, then you have left with, if you place S in the first position fixed, then you are left with 5 letters. And how many ways can it be arranged? It will be 5 factorial. That's why you have 120 ways. Now, the arrangement of the letter that does not begin with S, will now be 6 factorial minus 5 because you have kept the letter S fixed. That will be 6 factorial minus 5 factorial. Now 720 minus 120. That's how we got 60. Now, let's look at the last part. Now, you have seen the way the letter Sunday can be arranged 720. In how many ways can they be arranged if you do not begin with the letter S? You see that that's 600. Now let's go to the last part. Is if you place Y in the last position, how many ways can they be arranged? If you place Y in the last position, you are left with 5 letters. You have 120. Now, if you keep keeping Y in the last position and X in the last position, you are left with 4 letters, you have 24. So in how many ways can they be arranged? That will be 5 factorial minus 4 factorial, that's 96 ways. Now I've talked about circle and ring. In how many ways can 8 boys be arranged in a ring? 8 boys, that's go to the beginning of the note, n minus 1. 8 boys form a ring, that's n minus 1. So 8 boys will be n 8 minus 1 factorial, that's 7 factorial. In how many ways 8 different beads can be placed in a necklace? I told you I was explaining that when you have 8 beads can be placed in a necklace in 7 ways because you don't have ending. So now, arrangement counting from clockwise or anti-clockwise are taken differently. So the beads obtained by clockwise permutation is the same by the one obtained by anti-clockwise. So we can now say together in how many ways we can arrange a beads. Taking consideration of the clockwise and anti-clockwise, we now have 1 over 2 times 7 factorial. Let's go to the other part of the lecture note. In the other part of the lecture note, we want to look at combination. In combination is just a selection or a collection. In this collection, the order of the arrangement is not put into consideration. Like when we did permutation, we said that the order of the arrangement is put into consideration. So when we talk about combination, it's different way of collection or selection that is made out of a given set of things, taking some or all of them at a time without any regard to the order of the arrangement. We call it permutation. Look at this one. We can arrange this without taking the letter A, B, and C. Without putting the order into consideration, we can take A, B, 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 C, C, A, and B, A, B, and C. So when we talk about combination, we are talking of a selection from a given set, taking at some time or all of them at a given time, without the order placed into consideration. Now, what's the formula for combination? The formula for combination is, look at it, n combination R. To find n combination of n different things taken at R time is n combination R, but always know that R is less than or equal to n. So we can also say that combination is n permutation over R times, not over, times R. Look at it, n combination R is n factorial over R factorial multiply n minus 1, n minus R factorial. Now you need to know something. N combination 1 is n, taking R to be 1. N combination n is 1, that's taking R to be equals to n. N combination 0 is 1. Restricted combination. To find the number of combination of n different things taking R at a time with the following restriction. 1, let's say you have P particular thing must occur. 2, P particular things never occur. Now, if you say P particular things must occur in a combination, so you are going to have, let's first consider P particular thing be taken away. So you are going to have select R minus P from N minus P. It's like you have a collection of N different things and taking at arrow time. If taking arrow at a time, if you now say, okay, P must occur, so it's like you take P from R, that will now be N minus P combination RP. We'll explain that more when we do example. Now, If P never occur, in such case, you are going to have N minus P combination R if P never occur. Now, these are just some of when you add permutation, it's just a form of just algebraic expression of this n combination 1 plus n combination 2 plus n is n minus 2. That's just some theories. Now, in grouping, this is just also a theory, but I think I will go to using it to explain a problem. Let's solve problems. I think that's in how many ways can be college football team of 11 players be selected out of 16 players? Now, you have a set of 16 players and you want to make up a team of 11 players. How do you select it? You just say the n is your 16. The number you want to, your arrow, as you are taking at a time, it will be 16 combination 11. So that's how we have 16 factorial. Go back to the formula of combination. You have n factorial over arrow factorial bracket open n minus arrow factorial. So that's how you have 16 factorial, 11 factorial, 16 minus 11 factorial. That's how we got that. Now look at example 76. From a company of 15 men, how many selection of 9 men can be made so as to exclude 3 particular men? Now, I need to, you have a company, that's your N, and you want to make a selection of 9. See, there's a restriction, and you want to exclude 3 men. So, excluding 3 particular men in that case, you are left with making selection. You are to make selection of 9 men out of taking 3 men from 15. So, you are making selection out of 12 men. You have a company of 5 men. You are going to exclude 3 men from the selection of 9 men. So you are going to be left with 12 men. So the permutation will be 12 permutation 9. So that's why you have 12 permutation 9. That's how you got this. Now look at example 77. There are 7 candidates for a post. In how many ways can the selection of 4 be made among them so that 1, 2 persons whose qualifications are below par are excluded, 2 persons with good qualifications are included? Now you have 12 candidates for a post. In how many ways can you make selection of 4? Now, if you exclude 2 of them are below the qualification, so already you are excluding 2. If you exclude 2 out of 7, you are left with 5. So you are going to make 4 selection out of 5. So that's why you have when 2 whose qualification are below what you want, you are going to make a selection of 5 combination 4. You are taking 4 from 5. That's how you got this. Now, let's look at 2. 2 persons with good qualification are included. Now, 2 persons are fixed. So if 2 persons are fixed, you are to select only 2 out of the rest 7 candidates. Now, out of the rest 7 candidates, if 2 are fixed already, you are left with 5. So that's why you have 5 combination 2. You want to make a selection, you have 2 persons qualification included. They are like 2 persons are fixed, and you want to make a selection of 2 out. You take the 2 out of the 5, so you are left with 5 candidates. So you are going to make a selection of 2 out of 5. That's how you have 10. Now let's go to example 78. In how many ways can a committee of 3 ladies and 4 gentlemen be appointed from a meeting consisting of 8 ladies and 7 gentlemen. What will be the number of ways if Mrs. S refuses to serve in the committee, having Mr. Y as a member? The first part is, in how many ways can you get a committee of 3 ladies from 8 ladies? That will be 8 combination 3, you have 56. 4 gentlemen is selected from 4 gentlemen is appointed from 7 gentlemen. You are forming a committee of 3 ladies, that's this, out of 8. 4 gentlemen out of 7, that's 7 combination 4, you have 35. Now, in each of these selections associated with each other, you are going to see that for my first solution is this: how many ways can you select 7 ladies and 4 gentlemen from a committee, a meeting of 8 ladies and 7? You are going to have 8 ladies and 7 gentlemen. You have 56 times 35. That's how you got this. I've answered the first part of this question. Now, the second part of the question, I want to look at the second part, that both Mrs. S and Mrs. S and Mr. Y are members of the committee. Then we are to select, if Mrs. S and Mr. S is member of the committee, then we are to now select 2 ladies, because you already have Mrs. S included, and 3 gentlemen, because Mr. Y is included, from 7 ladies and 6 gentlemen respectively. That will give you, that's how we got 7 combination 2 times 6 combination 3. When you do that, you have 420. Now take it away from 1660. That's how you got this. Now let's look at example 69. In example 69, from 7 gentlemen and 4 ladies form a committee of 5 is to be formed. In how many ways can this be done to include at least 1 lady? There are possible ways you can form this committee. You want to form a committee of 5 and you have 7 gentlemen and 4 ladies, and you must include at least 1 lady. So there are possible ways. There are 4 possible ways you can form that committee. That's to say 1 lady, 4 gentlemen, 2 ladies, because you must at least include 1 lady, 2 ladies, 5 gentlemen, 3 ladies, 2 gentlemen, 4. The 4 way will be 4 ladies and 1 gentleman. These are the 4 possible ways you can form the committee. Now, look at it. We will now pick each of them. 1 lady can be selected from 4 ladies, that's 4 combination. You have 4 ladies, that's 4 combination 1. 4 gentlemen can be selected from 7 gentlemen, you have 7 combination 2. When you do that, you are going to have 4 combination 1 times 7 combination 2. You pick it, then you go to case 2. You are taking 2 ladies from 4 ladies, you are 4 combination 2. You are taking 3 gentlemen from 7 gentlemen times 7 combination 2. That's case 2. Case 3, you are taking 3 ladies from 4 ladies, you have 4 combination 3. You are taking 2 gentlemen from 7 gentlemen times 7 combination 2. The fourth case is you are taking 4 ladies. You are taking 4 ladies from 4 ladies times 7. You are taking 1 gentleman from 7 gentlemen. So what the total selection you are going to get For picking at least one lady, sum all of them together. Each of them you have done. On those four cases, you add them together. That's how you got the solution 414, 441 way. Now, in example 80, in how many ways can a boy invite one or more of five friends? Just a similar way. But here you now have a combination of, in how many ways can he invite one or more of five friends? So you are looking at one or more of five of his friends. Okay, if you invite one, you have five combination one. If you invite two, because it's inviting one or more. If you invite two, you have five combination two. If you invite three, it has five combination three. If you invite four, you have five combination five. And perhaps because it's inviting five or more, you can invite five combination one. Now, instead of going through this, go back to the theory. Can I just scroll back just to explain something to you? Look at this theory. This is what was applied here. So instead of me going to be picking each of them, the same thing as n 2 to the power of n minus 1. Now let's go to the last part in the note. I just want to pick example. Okay, I think I still need to explain. Now others, let's go to example 81. And in a group of 13 workers contains rather 5 women. In how many ways can a subgroup of 10 workers be selected so as to include at least 6 men? The 13 workers contains 5 women. In how many ways can a group of 10 be selected? 10 workers, and it must include 6 men. It must include at least, don't miss that word, at least 6 men. Now, you need to ask yourself, in that group, you'll be left with 8 men. You're left with 8 because we were told that you have 5 women. So that means from the group, you have 8 men and 5 women possible. Now, the possible cases you are going to have in forming 10 workers where you have at least 6 men. So you are going to have 6 men. You are going to have 3 cases. Case 1, you are going to have 6 men and 4 women in the selection. That gives you this fact, this combination. Now, case 2, I want to select 10 workers. At least 6 men. I'm going to have 7 men and 3 women. That gives me this combination. I have 80. Now, the third case I'm going to have is I'm going to have 8 men and 2 women. That gives me this. Because I can't go above this because I only have 8 men. I cannot say 9 men and no, I have just only 8 men, so I stop at 8. So when I add all this together, I'm going to have 230. Now let me look at example 82. In how many ways 15 things can be divided into 3 groups, 4, 5, and 6 things respectively? Now the first group will be selected in 15 combination 4 ways. In how many ways? You have 3 groups, 4 things, you have 15 things. The first one will be first group will be 15 combination 4. Now, already you have taken 4 from it, you are going to be left. The second group, you are left with, you have a selection in the box. You have taken 4 already from it. So you are now left with 11. So in how many ways will you pick 5? That will be 11 combination 5. Now, you are now left with, now you want to pick 6. So the last group will now be 6 combination 6. Because you have taken 5, you'll be left with 6. That's how you have 6 combination. 6, that's 1. So when you do that, you multiply it. You now have, yeah, the first group I took 4. The second group I've taken 4 from that, I'm left with 11. So assuming I have 15 and I've taken 9 out of it, I'll be left with 6. So that's how I have 6 combination, 6 for the last group. The same way you can as well look at example 83. A student is to answer 8 out of 10 questions on an exam day, in an examination. How many choices he has? That's 2. 2. How many if he must answer, in how many ways if he must answer the first 3 questions? 3. In how many ways if he must answer at least 4 of the first 5 questions? Now, it's a simple way. I think I only have solution for 2, and the other one will not be an issue because I've explained it earlier. Let me just explain the one. 8 question. In how many ways can it make sure 8 question out of 10? That is 10 combination 8. It's picking 8 out of 10. That's how you have this. Now the second way is that in how many ways if you must answer the first 3 questions. Now if you must answer the first 3 questions, so he has to make, and he's answering 8. So he's remain with 5. So then he's going to make, is remaining with 5. So he's going to answer 5 out of 7. So that means he's going to select 7 out of 5. That's if he must answer the first question. So now he now has to make 5 options out of 7 questions. That's how you have 7 combination 2. Now, I will not go further. These are part of things you practice yourself. So today we have looked at combination and we have looked at permutation. I expect you to go to your notes and practice what you have learned. And I want you to take example 8. 8 is 3 as I'm giving you as part of my assignment. So today we have done permutation and combination. I've rounded up the course. I hope another lecturer will take over from. And I'm going to give you an assignment which I'm going to send to you. Before the week runs out, I'm going to register you on Google Classroom. That's where you will submit your assignment. I encourage you to keep to the date of the assignment because the system will not allow you to submit if you exceed the day of the assignment. So thank you for attending the lecture. I will send you the material. Do have a lovely weekend.